let's consider the system that you see on the screen. And what we're going to do now is to make the bone graft model, put it into CampG, and then obtain the state space representation of this model so that we can using it Simulink. So the first thing we gotta do is to make the bone graft model and define the outputs because that's going to set the particularly the C and the D matrices. But we'll get started. In here, the first thing we're going to do is we're going to draw the bone graft model. In here, I am going to perhaps pick a different color pen so that be very clear. The current here, this is the put it I1, and I'm going to put another one for I sub 2 would be the current over here. Now this is very easy to draw it right on the screen, right on the drawing itself. Okay, like in here, this thing is a source of effort, this voltage source. Here we have the R element, and in here we have the I element, yeah. And in between these two, we have a, distinct currents here. There would be I1 minus I sub 2 will produce, what is easier to go up or down? Oh, we're going to go up. This is going to be the C element. Okay, so we go into the CampG software and we enter this in there. Okay, what do we want to go over here? Right here. CampG window in here. Very good. And then we will say file, and of course we're going to say new. Okay. I think this is what we want right here. We need to put this bone graft into the program. So in here, I'm going to go and do, this is the source of effort in here, and you have a 1 and 0. And what did I do? Oh, no, that's not what I intended. We needed to put the R element in here. And then the 0 belongs here. And then you have a C element that is up here. And so we join that. And then we have the 1 over here. We join like this. And then we have the I on the right hand side. Okay, so why don't we move a couple of these so they would look really nice. This is the bone graft model here. Could just move this to make it look a little prettier, that's all. Oh, undo. That be the worst. Well, you need to move just a little bit, not that big. This one, and move it down here. too far down. Let's try to move this a little bit up. There we go. And then we can move the C element to make it also look pretty. And then move, see? There we go. So with this, we go to the interface, but not to MATLAB, but to go to Simulink interface. What will happen here is that we are going to create some files and matrices that actually are initialized into the A, B, C, and D matrices that Simulink has. So okay. There we go. What happens is the CAMG Simulink interface is this one. You have a file that says CAMG ini is to initialize the files, and then you have one that says CAMG num. And what you want to do is to work with the CAMG ini file because that will initialize the values for the physical parameters. So so the Simulink, let's erase this one because we're not going to address the transfer function this way, but with this one, with the state space model. So what it's telling you is that CAMG has produced this form, and this block is going to have the data and the parameters and everything that CAMG set it up, and once you put in the numbers, it's going to have those numbers. So I would go over here first of all, and we need to learn what the system did. Okay, this is very similar to the CAMG SYM file, but it's not the same. In this case, you see it requires that we give some values to the parameters. In Simulink, it can't do it too well in the, it's not going to come out in the symbolic form, though you could use the expressions to do it. But because we of the type of variables that we have in here, we want to calculate first. We want to enter what the values are. And so what happens in here is that you could do the value, this say a 2 or 3, and C would be 1 over K, so 1 divided by 40 maybe. So those numbers, and then let's say this is a 2. Okay. Then what happens is the CAMG will initialize the A, B, C, and D matrices, but also we need to define what the outputs are. So in here, let's try to go back to the numbers and bond numbers that represent the system, and I am going to take a snapshot picture of this so that I can actually put it in the notes. see. Okay, so what I'm going to do is I'll just capture this and put it in the notes right here. This is the CAMG model. I mean, this is the model as entered in CAMG. That's what we're going to see. Model as entered model as entered in CAMG. So you have it. What are the outputs in here? In this case, as we had in previous example, the outputs is going to be the voltage C, you will say, and voltage across the resistor maybe. So these are the outputs. What is the objective here? Let's just do the objective. We have several. One, obtain the state space form. So obtain the space state form of the equations, of the system equations. So we have obtained the state space from the system equations, and then we want to find the transfer function between the P sub C divided by B and B sub R. So this is what we want. So far we have done what we needed to do. In here we went to the interface in Simulink, and that interface produced what we're dealing with right now. So what's happening here is this. CAMG-INI, we gave it some numbers, but we don't know, we didn't tell it what the output was. So can you tell me what the output is? Okay. So we have this in here. What would be the output? B sub C is E sub 4, right? And the voltage across the resistor is what? E sub 2? So if we go to the MATLAB editor in here, and we say, I want you to find where E4 and E2 are, because those are my outputs. So we're gonna find okay. I enter the parameters in here, and then I need to define the output. So yeah, but I want to use define, and I don't see here the where? Huh? Okay. Here we go. If we do it to E sub 4, see right there. So we need to activate this because the computer did not know what we really want. And if it is output 7, so we have the output in here, and the same thing for the other transfer function. And then we will obtain the, see, we go and run it. Let's run MATLAB. Oh, this is interesting. CAMG line 50, column 7, expression or statement is incorrect, possibly unbalanced. So line 50, let's go take a look. Line 50. Oh, no, here we defined, but we didn't tell it that it was the first row of the matrix. This is for E4. Yeah, this is the first output. And then, of course, this is the second one. And there's going to be one for E sub 2. Right there. So we go over here. I'll put 2 because we are considering 2 of them. Okay. So we go and say run. This is line 74, column 8. Well, this is 74, column 8. 74, column, yeah, this is the output. I gotta put 2s. So let's run. See, there it gives you the matrix, the B, the C, and the D. Okay, so this is what the matrices are. Now let me interpret what we have, and I think we should maybe cut from here like here, new. Okay, let's try. The thing is that it's not giving me my, yeah, here we go. Let's just get these results on a piece of paper here. We're gonna say new, and then this to here. Okay, so I'll just put it in the notes in there, what it is. Okay, where are the notes in here? Okay, so this is saying what the inputs and what the state variables are. And now what I would like to do is to bring in the matrices, because these are the matrices that are initialized in Simulink by doing what we did. So in here you have the A matrix. A matrix. Okay, let's do it here next door. See, this is the A matrix. We need to cut the B and the C and the D matrices to make sense of what we're doing right now. Here we go. These are the B matrix is still in planning here. B like that, and notes. What about the C and the D matrices? These are the C matrix and the D. So all it's doing is initializing variables. That's what this is doing. Okay, so we're gonna put the C on the D matrix. The D matrix is where was okay. Okay. One thing that is important is to understand how is this state space form written in here. Because you see, let's read this in here. Okay, it says that the input, no, that the state variables is PQ, P6, and Q sub 4. So that right there puts you, here it's gonna make this is the variables P sub 6 and Q sub 4 plus B, C, which is matrix B times the input, tells you what the input is E1. So this is the way the matrices are being set up. This one is P sub 1, right? P sub 6, excuse me, and Q sub 4. No. We need the derivatives. Sorry. And this one is written like this. So this is going to be P sub 6 dot, and this would be Q sub 4 dot, like this. And the C, you have the outputs that we saw. C is E sub 4 and E sub 2, and we have to have the same state variables, same layers in here. And then we have, this is the, oh, we didn't copy the D matrix. I thought I had done that, but sorry, we need to copy the D matrix. Oh, we did copy, I just didn't paste it. That's what's happening. This is the D matrix. Okay, so what are we seeing on these equations here? See, this is the matrix D, So the state variables are going to be the same. This is going to be P sub 6 and Q sub 4, and this is the matrix D, and then times the inputs. Okay, times this input. What do we have? E sub 4. And the other one, it was E2. Yeah. Okay, so in here we need to erase this. So these are the statements. Well, Simulink, the block in Simulink contains those matrices. In other words, this block right here, I'm just gonna maybe cut here. Let's put this in the notes. The way this works is this block has been created in Simulink with these matrices that you see here. See, this is what's new for you. Create with the matrices over here. So what happens is that we could potentially do the simulation of a step and an impulse response as default inputs, and then calculate the output for E sub 4 and E2. Okay, so we will see later on that we can also do this with a computer-generated transfer function. But for using the state space block in Simulink, these are the matrices that we're operating with. So if we go back here, you see E4 and E2 are the outputs. Oh, there's a small correction right here that I just noticed. Please excuse me, there's a little error in here. This has to be the outputs. I mean the input. So that is the matrix, and this is the number. I mean this is SE1, and we need to. Yeah, we need to go over here, and this is, yeah, here is, I need my cursor back. This is, SC1. Okay, so if you're talking about this, when we go to Simulink over here, this is my input. There's only one, so I'm just gonna say one input, please, not two. We know that in this case there's two state variables, so I could copy this and do the other two, okay, and then go like this. Where this one is going to be, you know, we know this is a scope, but this would be E sub 4 as the outputs, and this is going to be E2 in the same order that see here this is gonna see here's 2, huh? So in here we can put the name over here and say this is E sub 2. And if I do this and this, I have two outputs in Simulink. And if I go over here to run, this should work. And it does. I just run it. See? So this is the step input in here, and this is ISO 4 and an ISO 2. So this is the way the this works, because you have in the background working with the A, B, C, and D matrices, and we are working in the time domain. Okay? So the two outputs that we have are supposed to be in the same order than they were specified on this C matrix. See right here, E4, E4 and E2. So the first one is E4, the second one is E2. But when you are doing this, notice in here that uh, the the outputs are just this, but in here, if you double click, you see these are the A, B, C, and D matrices. We set all the initial conditions to 0, but we can get the outputs in here. But this this block contains everything, contains this derivatives and the outputs in here. So it is in here the situation where the outputs are E4 and E sub 2, but the block in here contains also the fact that the state variables are P sub 6 and Q sub 4 in the way indicated right here. Yeah. And also those are the same state variables on this equation also. But this is how it works.